Hello children, welcome to my channel. Now this is a continuation of real numbers. In this video, I am going to mainly focus on proving that root 2 is irrational. In order to prove root 2 is irrational, there are two more important theorems, one of them being fundamental theorem of arithmetic, which I will explain. The fundamental theorem of arithmetic states that every composite number can be expressed as a product of primes. This factorization is unique apart from the order in which the prime factors occur, which means that if I look at this number 32,760, I'm writing it as a product of prime numbers, prime factors. This factorization is unique, that is, you cannot get rid of 1, 5 or 1, 7. And also that we can of course change the order in which we write these numbers, write these prime numbers. But it's still going to remain as a product of prime numbers. The next important theorem is let P be a prime number, and if P divides A square, then P divides A also. That is, if P divides a square number, then P divides its square root also, where A is a positive integer. So I have taken three examples over here. This one, first one being the 7 is a prime number and 7 divides 441. That is, when I do 441 and I divide it by 7, I get 7 6 are 42 and 21 and 7 3s are 21 and the remainder is 0. That is 7 divides 441, which also you know, and also you know that 7 divides the square root of 441, which is equal to 21. Second example is 3 is a prime number. 3 divides 81. You know that 3 divides 81 perfectly. And you also know that 3 divides the square root of 81, that is 9. And the third example, 11, which is a prime number. 11 divides 1936. And also 11 divides the square root of 1936, which is 44. Now, these two theorems are required in order to prove the next important result, that is root 2 is an irrational number. To prove that root 2 is irrational, we are going to use the method of contradiction in order to prove that root 2 is irrational. So what we do is we start off with supposing that root 2 is rational. We'll come to a situation where we show that it contradicts our supposition, and therefore we will conclude that root 2 is irrational. So let's start. Suppose root 2 is rational. Then by the definition of rational numbers, you know that there exist integers r and s where your denominator is not equal to 0. We can write that root 2 is equal to r by s. So that is, you have already done it as p by q. So here we are writing it as r by s. Suppose r and s have a common factor. That is, for an example, as an example, I am taking 42 divided by 36. That is, suppose root 2 I am expressing it as 42 upon 36. Then you can see that there is a common factor 6 between 42 and 36. So I will get, when I remove the common factor, when I write it in its simplest form, it will come to 7 by 6. So suppose r and s have a common factor other than 1. Then we divide by the common factor to get root 2 is equal to a by b, where a and b are co-prime. Co-prime meaning there is no common factor between a and b other than 1. I'll take the b that side, that will be b root 2 is equal to a. When I square this, on squaring, I will get 2b square is equal to a square, which implies that 2 divides a square, that is 2 is a factor of a square. But in my previous theorem, I have already said that 2 divides a square, it implies that 2 divides a also. To prove root 5 is irrational, again I use the method of contradiction, but in this question, I am not going by the whole thing that is root 5 is equal to r by s, where r and you are talking about a common factor and then dividing by the common factor. You need not go by all that, except for root 2, where you are writing down all the steps. For the remaining questions, you don't have to do that. We can directly write down that suppose root 5 is rational, then there exist integers a and b such that root 5 is equal to a by b, where a and b are co-prime. Directly we are writing down a and b are co-prime. So b into root 5 is equal to a, and on squaring we get, this implies on squaring 5b square is equal to a square. Therefore 5 divides a square. But 5 divides a square implies 5 divides a also, which means we can write a is equal to 5c for some integer c. From here, I am going to therefore square on both sides. So I'll get a square is equal to 25c square. So I get over here, if I take this as 1 and if I take this as 2, from 1 and 2, I get 5b square is equal to 25c square, implies b square is equal to 5c square. So 5 gets cancelled, I get b square is equal to 5c square. Therefore, again I am saying that 5 divides b square. 5 is a factor of b square, which implies that 5 divides b. But here I said 5 divides a, and here I am saying 5 divides b, implies 5 is a common factor of a and b. But this contradicts the fact that a and b have no common factor other than 1, because I said a and b are co-prime, which contradicts our assumption that root 5 is irrational, and therefore we conclude that root 5 is irrational. To prove that 1 by root 2 is irrational, again I use the method of contradiction. Suppose 1 by root 2 is rational. Then there exist integers a and b such that 1 by root 2 is equal to a by b, where a and b are co-prime. So I take b this side and root 2 this side. So I'll get b is equal to a root 2. And this implies that on squaring I get 2 times a square is equal to b square, which implies 2 divides b square, and this implies 2 divides b also, which means I can write b is equal to 2c for some integer c, and therefore on squaring I'll get b square is equal to 4c square. Now I have over here, this is 1 and this is 2. So from 1 and 2 I get 2a square is equal to 4c square, which implies a square is equal to 2c square. Therefore 2 divides a square, and which implies 2 divides a. So I have got 2 divides b and 2 divides a, and that means 2 is a common factor of a and b. But this contradicts the fact that a and b are co-prime, that is, there are no common factor other than 1. Which means it contradicts our assumption that 1 by root 2 is rational, and therefore we conclude that 1 by root 2 is irrational. Now to prove that 3 plus 2 root 5 is irrational. Suppose 3 plus 2 root 5 is rational, then there exist integers a and b such that 3 plus 2 root 5 is equal to a by b, where a and b are co-prime. This is a very important sentence you should be writing. Now what I do over here is I take 3 to the other side. So I will get 2 root 5 is equal to a by b minus 3. I'll take the LCM on this side, that will give me a minus 3b divided by b, and then I bring 2 down into the denominator, so I'll get a minus 3b divided by 2b. Since a and b are integers, a minus 3b upon 2b is going to be rational. But so what is happening is, this side is rational and this side root 5 is irrational, we already know. But we know that root 5 is irrational. So this again contradicts our assumption that 3 plus 2 root 5 is rational, because you are saying on this side is rational, this side is irrational, which means there is a problem with our supposition. So this contradicts our assumption that 3 plus 2 root 5 is rational. So we conclude that 3 plus 2 root 5 is irrational.